Okay, so we've already looked at solving by elimination. We have two equations. We want to find out what is their point of intersection. So let's take a look at what this looks like graphically. We can have two equations, and of course they meet at a point. Whoops, there we go. Two equations, they meet at a point. However, we can also have two equations that are parallel and never meet. So they're not going to have a solution, because the solution means where do they meet, or that they meet. So no solution means they don't meet. One solution means they meet at one point, and many solutions means they have two lines, but they're really the same line, one right on top of the other. So they meet at an infinite number of points. So most times when we solve a system is a fancy word for two lines. Most times when we solve a system, we have a point where they meet, one solution. But the odd time we have one of these two cases, which is where they meet nowhere or where they meet everywhere. Now let's take a look at the algebra. Here's the picture, the graphing. Let's take a look at the algebra and see what that looks like. So we've got equation 1 and equation 2. So I'm going to rearrange this equation 2 so it has y equals negative x plus 6. And then what I'm going to do is I am going to sub it into equation 1. You have to always sub into the equation you did not rearrange. So I have 2x plus 2y equals 7, and I know y equals this, so I'll just sub it in here, hence the name substitution. Now I'm going to do my simplification, so 2 times negative x is negative 2x, and 2 times 6 is 12, equals 7. Now these cancel out, so I have 12 equals 7. Now as you know, 12 never equals 7. That's just not the way things are. 12 equals 12. 12 equals 11 plus 1. 12 equals 6 times 2, but 12 never equals 7. So when you get in algebra, in writing, as opposed to picture, something that is nonsense, you know that the picture will be something like this, where these are parallel lines and they just do not meet. And this shows you that there is no solution. Now, what does it look like when you have a system that has an infinite number of solutions? Well, let's see here. So here we have equation 1 and 2, and let's see, I'm going to sub in y with this because it's already in y equals. Usually we have to rearrange for some y equals or x equals, but in this case they gave it to us. So I'm going to take equation 2, and instead of y, I'm going to write what y equals, which is 2x minus 3. So here I've got 6x minus 9 equals 6x minus 9. Well, no kidding. Of course 6x minus 9 equals 6x minus 9. But let's just continue solving. I'll bring this 6x over here. And we know that when something goes over the equal sign, it changes from positive to negative or negative to positive. So 6x minus 6x is 0. 9 minus 9 is 0. And unlike up here where this was never true, this is always true. There's no variable to plug in or anything. It's just 0 equals 0. We know this is always true. So always true graphically will look like this. This is the line, and these are all the always true. These are all the points. an unlimited, infinite number of solutions. So here, I didn't write the answer. Here I would write, therefore, no solution. And here I would write, therefore, infinite solutions. And that is how you solve the oddball cases of no solution and infinite solutions. But remember, most times you're going to find that you have this kind of scenario where you have the lines meeting at one point. And in our previous video, we did an example of that, where we had two lines, we subbed in, found out what x equals, found out what y equals, checked to see that the left side equaled the right side, and then when it did, we wrote that xy equaled the point. All right, have a great day.